Today we will discuss about fresh air calculation, how to calculate the capacity for FHU, energy recovery ventilation, and the fans. Okay, as per ASHRAE standard. Okay, before we go into the calculation part, I'll just explain you the purpose of fresh air calculation. Okay, see there is a ASHRAE chapter 11. This we have discussed about air contaminants. Okay, so we will understand that why the fresh air is required inside the building. Okay, you can see that air contamination is a concern for ventilation engineers when it causes problem for building occupants. Okay, so you can talk about in the air you have a properties like 78% nitrogen and 1% argon. Okay, 21% oxygen, the other gases like 0.04% of carbon dioxide, and there are some other gases which comprise total of 100%. Okay, so that is the composition of air. Clear, right? Okay, so when you talk about in the air, you can say that there are contaminants that present particular problems in the indoor environmental include dusting, okay, allergens, antigen, tobacco, smoke, okay, radon and formaldehyde. Okay, so these are the things present in the inside the air. Okay, so that should be taken out from the building so that the human have indoor to maintain indoor air quality, right? So you can see there are a lot of dust, fumes, smokes, mist, fog, smokes, and also there will be moisture in the air inside. Okay, so that will increase the humidity of the space, right? So that is why the purpose of fresh air ventilation. Clear, right? So if you go to ASHRAE 62.1, okay, if you refer ASHRAE 62.1, it talk about for acceptance of indoor air quality. Okay, what is the acceptance level we have to maintain in the indoor air quality? Clear, right? So this is we are going to talk about ASHRAE 62.1. Okay, when you design the FHU, okay, or any of the machines, okay, there are two parameters required. Okay, one is the air flow rate, and then the second one is the tonnage of the equipment tonnage, right? So when you talk about, you have a two type of fresh air handling unit. One is the treated, another one is untreated or non-treated. Okay. So when you talk about treated fresh air, we will talk about fresh air handling unit or one-way air handling unit, something like that, right? Okay. But when you talk about non-treated fresh air, you can talk about like energy recovery ventilation unit. Okay. It doesn't pass through the cooling coil. It just directly take the air from outside and it exchange the energy between indoor and outdoor. Clear, right? Okay, then when you talk about fans, say for example, there are some spaces like toilet fans. Okay, so you are going to calculate the toilet fan capacity. That is based on again ASHRAE 62.1, 2019 or the latest version 2022, 23, something like that. Clear, right? Okay, if you go to this standard, there is a equation how to calculate fresh air ventilation. Okay, you can see the equation here. Breathing zone outdoor airflow rate. The outdoor airflow rate required in the breathing zone of the occupied space or space in a ventilation zone shall not be less than the value determined in accordance with the equation 6.1. Clear, right? So this is the equation V equal to R into P plus R into A. Okay, so what they are speaking about, if you go to my Excel sheet, one of the Excel sheet I will be sharing. Okay, so you can see the fresh air, how to calculate the fresh air capacity. Okay, the airflow rate. So this is based on the ASHRAE 62.1 category. You have a fresh air and then you have an exhaust air, right? Then you have a different spaces. Okay, then you have a floor area. Then after that you have occupant density. Clear, right? Then after that you have a outdoor rate, air rate and exhaust air rate. So here, this is what you are going to calculate. Okay, when you see here RP, okay, when you go to this particular standard, it mentioned RP multiplied by PZ multiplied by RA plus multiplied by AZ, right? So this is what it is described here. Okay, when you talk about RP, there's nothing but number of people. When you talk about RA, they talk about the area. Okay, when you talk about PZ, it's talk about occupant, how many occupants. Clear, right? Then this is the area. When you talk about AZ, it's the area. Okay, so here you are going to calculate the fresh air requirement. Okay, so what is the equation? Fresh air is nothing but VBZ equal RP multiplied by PZ plus RA multiplied by AZ. Clear, right? So if you go to ASHRAE 62.1 standard, you have a different category. Okay, there are, if you go to occupancy category, you have animal facilities, then you have a correctional facilities, educational facilities. Okay, then you have a food and beverage service general. Okay, there are different occupancy category, hotel and motels. Okay, then you have miscellaneous spaces. Okay, then you have office building, outpatient health care facility. There are different type of occupancy categories there, right? So here they have given the value. Okay, so that is what they have explained here, right? So they said that whatever the outdoor airflow rate required in the breathing zone shall not be less than the value determined in accordance with the equation 6.1. So whatever the value we are selecting 6.1, the table should match. So for example, assume that I have office building, right? So if we go to office building, say for example office building, okay, you have office spaces, right? So what is the fresh air required for the people? 2.5 liter per second per person. So each person required 2.5 liter per second. Clear, right? And for the area, each per meter square of area required 0.3 liter per second. Clear, right? So this table, this value you will take and you will tabulate here. Okay. So say for example, I have office area. So this Excel sheet is prepared as per as 62.1. You can choose any of the occupancy, right? Occupancy category. Assume that I have an office space. So then just click O. Then it will come office spaces. Click here. Then it will change based on that. See here, 2.5 liter per second for the people and 0.3 for the area, right? So it will calculate accordingly. So area is as per the diagram. You're preparing layout for multiple spaces like office area. Then you have a reception. Then you have a pantry. You have a corridor. Okay, you have a multiple spaces in your architectural drawing. So you are going to categorize which category in your particular spaces you are going to calculate, make that particular spaces. Then you are going to select what is the type of the building. Okay, say for example whether it is office space, right? And this is for the fresh air category, and this is for the exhaust air category, and this is the occupant density. So occupant density, how we are going to calculate? There are two methods. One is based on furniture method. Another one is based on ASHRAE method. So ASHRAE method, if we talk about here office space, you can occupy 5 people per 100 square meter, right? If it is a reception area, you can occupy 30 people per 100 square meter. Okay, so that is what this is a way to calculate number of people. Clear, right? Okay, so here if you go to this particular table, okay, you can calculate number of people based on ASHRAE 62.1. But as per actual furniture layout, maybe 2 people, right? So you have to compare whether which is the least method, right? Maybe as per furniture method, only the 2 people going to sit in that area. You don't require to consider 10 people as per ASHRAE, right? So you can take the actual number of people. Okay. In case if your furniture says 15 numbers, okay, if it supersedes your ASHRAE 62.1, yes, you can take 15 numbers as per the ASHRAE guideline, as per your furniture layout, right? Okay, then the toilet fixtures inside, if there you have any toilet fixtures or if you have any different type of plumb fixtures, you can list out all the fixtures. Okay, so now I'm going to calculate fresh air and I'm going to calculate exhaust air. So the exhaust air, how I will calculate? If I go further down, okay, I can see the category for the exhaust, right? You can see the 6 minimum exhaust rates for different type of category like animal facilities or animal procedure room or hot class rooms, okay, where the bad smell expected, right? Like cells with the toilet or dark rooms or kitchenettes, or you can say shower rooms, okay, or parking garages, okay. Then you have a toilet, different toilet like private toilets, public toilet, right? Okay, so here there is a category. If you read this particular notes, read note A to I, okay, they have given here. Say for example, toilet private, okay. So E and H. What is E? The rate is for a toilet room intended to be occupied by one person at a time, right? For continuous system operation during hours of use, take the lower rate, okay, which is 12.5. Okay, if it is like a uncontinuous operation, okay, like say for example, whenever you operate the toilet, that time you are going to switch on that toilet fan. So that means it is not a continuous operation. So you have to take 25 liter per second. Clear, right? So they have given the conditions here. So based on that condition, you have to take the flow rates. Here again for residential kitchen, you have a condition G. G is nothing but for continuous system operation, the lower rate shall be used. Otherwise, higher rate shall be used. So if your residential kitchen, if you say for example, I have a residential kitchen, I have a exhaust continuously. Okay, in that case, you will take 25 liter per second. Otherwise, assume that whenever I'm going to operate kitchen, I'm going to switch on the fan, you will take 50 liter per second. So that is the condition says as per ASHRAE 62.1. Clear, right? So now you have a flow rate for exhaust and you have a flow rate for fresh air, right? How to calculate fresh air based on this equation, and exhaust air you can calculate based on the fixture, right? What are the fixtures? There are toilets fixtures like a WC, like urinal. You can see that the D, like rate is for per water closet or urinal or both. Provide the higher rate where period of heavy use are expected. Okay, so if it is a heavy use, you will take the higher flow rate. If it is like a normal usage, you will take lower flow rate. So depends upon the operation. Okay, so that is what this particular exhaust rate it is given. It is based on either based on the exhaust air rate based on the area or based on the fixture unit, right? So there are two conditions. Okay, if it is based on area, this is the value. If it is based on fixture unit, this is the value. If you have a both, then you will multiply by both. Clear, right? But normally, as per ASHRAE 62.1, it says that either you take as per area or you take as per fixture rates, right? So this is what you can see the table here, right? Okay. Now, if I go to the table, okay, if I go to the table, I have to calculate my fresh air requirement. So how I calculate fresh air? People, fresh air. What is the people required? Fresh air for the people multiplied by number of people plus what is the area fresh air required per square meter multiplied by total square meter. So then I can calculate the fresh air requirement. Okay, then the exhaust air requirement I'm going to calculate the fixtures or for the area multiplied by how much liter per second either per meter square or per the fixture. Okay, then I can calculate the exhaust flow rate. Clear, right? Okay, now I am going to calculate. I'm going to compare, okay, right? For example, which is the best value. Say, for example, I'm going to calculate fresh air, right? I'm going to calculate fresh air and I'm going to calculate exhaust air. Okay, so assume that I have to create a positive pressure or negative pressure. Okay, where I will create a positive pressure, where the human living, okay, or where I don't want taken away from the breathe, bad spacing, bad smells, right? So that particular area I have to create a positive pressure. Okay, where I have to create negative pressure, such as like kitchen or pantry, or where I am expecting bad smell, I have to create a negative pressure because the smell may spread outside the room, right? It will go and to the neighbor space that will disturb the other people, right? So where I have to decide where I'm going to create a positive pressure, where I'm going to create negative pressure. Okay, if I make positive pressure means the fresh air is more than the exhaust air. If I create negative pressure, the exhaust air is more than fresh air. Clear, right? So based on that, I'm going to calculate my total fresh air requirement and exhaust air requirement. Clear, right? So whether it is for pantry makeup or pantry exhaust or garbage exhaust, whatever it is, I'm going to calculate what is the fresh air required for that space and what is the exhaust air required for that particular space. So I will be calculating for each and every category, right? For example, office category, toilet, okay, then bedroom, living, like that. I'm going to calculate for different spaces. Then I will be arriving with for total building, like say for example corridor, right? So I have a different spaces. Okay, then I will be calculating for all the space. Then I will come with the total my building. What is my fresh air and exhaust required, right? So I will be calculating what is the fresh air and what is the exhaust air required for that particular building. Then I will decide how to segregate my FHU. See, if I calculated, I have a total this much fresh air and for this much for the building, this much exhaust. Okay, then I have to categorize my FHUs. Okay, how I'm going to serve my building. Assume that I have a building like L-shaped building. Okay, this L-shaped building. Okay, so I cannot provide with one FHU to serve all the spaces, right? So what I will do, I will go with one of the FHU here. Okay, assume that I will go with one FHU, then I will serve within that spaces, right? Then I will go with another FHU, say for example this particular spaces, right? Okay, then I will go with another FHU, then I will serve. Depending upon we think you are to get the designer to get the policy person policy person planning out into input for the specific first. Okay, then I will decide, say for example, this is the FHU, then I will decide that I will be serving through nearest area. So I can decide how many number of FHU I can go with, right? Because if the airflow rate is very higher, also my duct size will be very larger. Then I cannot able to accommodate within the shaft. So based on that, I can able to categorize number of FHUs. Clear, right? Anyone have doubt how to calculate fresh air airflow rate and exhaust airflow rate for the FHU? So everyone clear? As per ASHRAE
Yes, sir.
62.1, how to calculate fresh air and exhaust air.
Yeah.
Clear,
Yes, sir.
right?
Yes, sure.
Yeah.
Yes, sir. Clear.
Okay. Let me take out one equation. Okay. Now we are going to calculate the tonnage, right, for the FHUs. Okay. Let me take out one equations. See, this is the HVAC equation for air side, right? You can able to see the screen. Okay. So how to calculate sensible load? This is the equation 1.08 multiplied by CFM multiplied by delta T. Okay. And how to calculate latent load? 0.68 multiplied by CFM multiplied by humidity ratio, right? And if you want to calculate total load, which is nothing but 4.5 multiplied by CFM multiplied by delta H. So this is the equation to calculate the sensible load, latent load, and the total load. So everyone clear? Clear, right? Anand, Soji, and
Yes, sir. Clear. Clear.
Sushant. Okay, right.
Okay, Jay.
Understand.
Sure.
Yeah.
Yeah.
Yes.
Equation.
Now I'm going to explain. Okay, there are different type of FHUs in the MEP industry, right? Okay. Let me clear this portion. Okay. Okay. I will come to that portion. Before that, let me open the SAFOT regulations. Okay. If you see the SAFOT regulations, what they are saying, chapter 5. If you go to this area, you can read. Okay. The heat load calculation must be carried out for each condition space, considering peak load incident in that space. The calculation must be carried out using software registered with Dubai municipality, which is HAP software. Okay. So whenever you do the HAP thermal load calculation, you will be able to do with the HAP software only. Okay. That is approved with Dubai municipality. Okay. Then all new air conditioned buildings shall be provided with a fresh air. The system must ensure that building is provided with a treated fresh air for at least a 95% of the year. Clear? The design temperature that needs to be considered as follows. So what is the dry bulb temperature? 34 degrees Celsius. Okay. And wet bulb temperature will be 32 degrees Celsius. Okay. But what is the peak temperature in UAE? If you talk about peak temperature, it is 46 and 29 degrees Celsius. Okay. But if you go to the season for the entire year, okay, the 34, 32 will be the most humid condition. That is why we calculate FHU based on 34, 32. Clear, right? So if you calculate either by 34, 32 or 46, 49, 46 and 29, the load will be higher, okay, in 34, 32 degrees Celsius, because the humid load is very higher. Clear, right? The humidity in the air is very higher. So that is what we have to take out, okay? That is why the purpose of the fresh air is to remove moisture from the space. Clear, right? So that load is much higher. Okay. So if you go to this guideline, okay, you can see the different type of FHUs. One with the cooling coil, one with enthalpy wheel plus cooling coil, and another one is enthalpy wheel plus cooling coil plus wraparound heat pipe, right? Enthalpy wheel plus cooling coil plus sensible wheel, and enthalpy wheel plus cooling coil plus passive desiccant wheel. Okay. So these are the types of FHUs available. Clear, right? So say for example, I have a one FHU, right? So this is the FHU where I have the filter. Okay, then I will be having a cooling coil, then I have a blower, then I am going to supply into the space, right? Okay. If you talk about here, what is the condition? Outdoor air condition and the after the coil and before the coil, right? So the condition 1 is before the coil and condition 2 is after the coil. Okay, you can see the two conditions. Okay, one is based on peak condition, which is 46.1 and 50 percentage or 29 degrees Celsius, right? Wet bulb temperature. So if you talk about this condition, what is the total load? Which is 98.6, right? And if you go as per SAFOT regulation, which is 35 and 32 degree, and you can see that which is the higher one, 99.3, because here the humidity is more. That is why the load of the FHU is higher. That is why normally we consider whenever you go with the calculations, you will calculate based on 34, 32 and what is the supply temperature is required for the space. So that is the delta T, right? So 34, 32 and what you are going to achieve after the coil, it will be low temperature, okay, which is you will cool lower than 14.4 degrees Celsius, okay. So that 14.4 degrees Celsius is the maximum dew point temperature, right? Okay, so you are going to cool lower than that temperature. Clear, right? Okay. In that way, you can able to calculate what is the delta T, right? If you have a conditions, okay, if you go to the psychometric chart and if you plot the value based on this one and this one, you can able to calculate the condition 1 and condition 2. So clear, everyone? Condition 1, 46 and 50. If you enter into the psychometric chart, okay, let me go to the psychometric chart here. So you go to the psychometric chart, you can able to enter the value here 34 and 32 wet bulb temperature. You can able to calculate all other conditions like relative humidity, dew point temperature, then humidity ratio, then enthalpy wheel. Okay, then you can calculate specific volume. Everything you can calculate, right? Then if you talk about off coil condition, which is 12.78 and 9.28, right? So if I go to the psychometric chart, 12.78 and enthalpy 35.98. Okay, assume it is close to the dew point condition, right? That is the off coil condition. So when you go to this particular psychometric chart, you can able to get the conditions of the air, get the properties of the air at point 1 and point 2. So in this way, you can able to calculate sensible load and latent load. Also, you can calculate if you want to calculate total load, or if you want to calculate sensible load, or if you want to calculate latent load, you can able to calculate by using these two conditions. Clear, right? So if I go to my equation, okay, what it says, my equation is says
Actually,
one. Yeah, tell me. Yes.
I'm just confused with the how to select that off coil condition. Actually, that's what I'm a little confused.
See, the off coil condition will be very low temperature, which is between 10 degree to 11 degree, okay, or 12 degree, something like that. Okay, so that one I will explain you separately how to calculate the supplier temperature. Okay,
Okay.
there will be chart. There will be chart. Okay, so in that way you have to calculate. You heard about ADP, right? Apparent dew point temperature.
Yes.
Okay, that
Yeah.
I will explain you separately. That will take some time. How from the outdoor condition to the mixed condition. Then after that, you have to go to the returner condition. Then after that, you are going to the coil temperature. The coil temperature. Say for example, if you talk about chiller, right? So say there are chillers available. Say for example, 7 degrees Celsius, and you can say that 12 degrees Celsius, right? The supply temperature
Yes.
or the discharge will be 7 degree, and the which is going to the chiller will be 12 degree. Okay. So actually speaking, your air should be cooled at coil temperature, which is 7 degree. Okay, that is the apparatus dew point temperature, but it cannot cool because of the bypass factor. Okay, what is the bypass factor? There will be air will be escaped between the coils, right? So that will not have any energy transfer. Okay, so that because due to that, your supply temperature will be higher than the coil temperature. Okay, which will be assume that you have a 7 degree. Okay, but it should be 7 degree, but it will go at like a 10 degree or 11 degree, something like that, because of the bypass factor.
Okay.
Okay, so I will explain you how to calculate bypass factor. That I have some video as well. I will be sharing you the video, but we will discuss about bypass factor, everything. Okay.
Okay, sure.
You're clear, right? Okay.
Yeah.
Okay, so here you are going to calculate what is the sensible load and total load and the latent load. Okay, so if you go to my calculations here, you can able to see here what is the sensible load and what is the latent load, how you calculate it by using that equations. Is that clear, right? You have a condition 1, you have a condition 2, and in the condition 1 you have a dry bulb temperature, then you have a humidity ratio, you have enthalpy. Okay, then you have a condition 2, you can calculate your dry bulb temperature, humidity ratio and enthalpy. So to calculate sensible load, what is required? 1.08 multiplied by CFM. This CFM only be calculated by using the ASHRAE 62.1, right? And multiplied by delta T. What is the delta T? On coil and off coil temperature. the on coil temperature will be same as external temperature, and the off coil temperature will be lower than dew point temperature, which is 14.4 degrees Celsius. Okay, because the temperature will be approximate 10 degree or to 13 degrees Celsius. Okay, something like that. So that will have an exact value we can calculate based on the bypass factor and based on the apparatus dew point temperature. Clear, right? Okay, so by using this equation, you can able to calculate total load or sensible load. Okay, so this is what it is given here. So this is the capacity of the FHU. So when you go to any of the FHU capacity, okay, normally what you have, say for example, this is one of my project, right? Okay, you can see schedule of air handling unit. So what is required? Normally unit rate, unit reference, area served, then supply rate, airflow rate, which you calculated based on ASHRAE 62.1. Okay, and what is that air on coil temperature, air off coil temperature based on that exercise what we did just now before, and the capacity, you have a total kilowatt and sensible kilowatt. Okay, you calculated based on the equations, right? And what is the chilled water temperature you are going to select based on what is the type of chiller you are going to select, right? Say for example, sometime 6 degrees Celsius and 14.8. This is based on Tabreed, okay, like the district cooling, the chilled water supply provider, right? Okay, so based on that, this value will be derived. So based on this equation, you can able to calculate chilled water flow rate. There is another equation. Okay, is everyone clear? So if you know this value, you can able to calculate the fresh air handling unit schedule. Okay, so if I go to another type of AHUs, okay, so this is one way FAHU, right? I want to save some energy. Then what I can choose? I can choose another type with heat recovery wheel. Okay, so this heat recovery wheel, you can see that condition 1, 2, 3, 4. This is on coil. Then after the heat recovery wheel, okay, and before the coil and after the coil, right? So this is the software available. There are different manufacturers. They can provide you the software. Okay, you can able to mention the return air airflow rate and the indoor airflow rate, the outdoor how much you are going to supply the airflow rate, and what is the temperature from the building. Okay, and what is the type of the heat wheel. It can tell you that what is the on coil temperature and off coil temperature at condition 1 and 2. Then the same condition 1, 2 will be enter into the coil. Then after that 3, what is the 3 temperature? It is almost less than 14.4 degrees Celsius, which is less than dew point temperature, which is 12.78 degrees Celsius, right? So this is off coil condition. So by using this equation, you can able to calculate your sensible load and total load. Clear, right? See, by using without heat wheel, your capacity of the machine is 98.6. Okay, if you use the heat wheel, your machine capacity is 37.68. So this is the energy saving. Okay, so if you go with any of the manufacturer, they use the heat wheel, right? In India, there are famous heat wheel like a DRI. Okay, there are different manufacturers are available for the heat wheel. So based on the heat wheel, you have energy saving. Okay, then there is another options that where you can use the pre-cool and post-heat pipe. Okay, by using this, you can save energy, right? So here what we are going to do, okay, if you go to this conditions, okay, you are going to supply at 12.78 degrees Celsius. Okay, but I don't want to supply at 12.78 degrees Celsius. I want to increase the temperature. I want to supply at like, say for example, after the coil, okay, I have a 17 degree or 16 degree. I want to increase the temperature, right, to match with my room condition. Okay, so what you are going to do, you are going to use pre-cool or pre-heat pipe. Heat pipe is to increase the temperature after the coil, because say for example, I have one space, right, and this is my FCU, and I'm going to supply with the ducting, right, with the diffuser, everything. Okay, here I'm going to supply with some temperature which is like a less than dew point temperature, which is 14.4. Okay, I'm going to supply at low temperature, and then it will absorb the heat. Then it will maintain at room temperature, which is 24 degrees Celsius. Clear, right? Okay, now I'm going to take out some of the air and I'm going to supply the fresh air. So to maintain indoor air quality, I'm going to take out some air by means of exhaust. I'm going to supply some fresh air. So this fresh air should be equal to the room temperature, because I'm not going to supply this fresh air for the cooling purpose. I'm going to supply this air for the replacement purpose. Whatever the exhaust I have taken out to maintain indoor air quality, right? So I'm going to maintain the room temperature, which is 24 degrees Celsius. But what will happen after the coil? I am always getting 12.78, which is low temperature. Okay, I want to increase the temperature. Either I can use heater to increase the temperature, or I can use double heat wheel to increase the temperature. See, when I use the double wheel, what is the condition? 4 condition, which is 20.64, right? I want to increase the temperature. After the coil, 12.78. But I'm going to use the sensible wheel to increase the temperature. Either I can use sensible wheel, or I can use heater, or I can use a pre-cool or post heat pipe. I can use anything, okay? But I have to see that what is that energy consumption. If I use post heat pipe, maybe energy consumption will be say 3 kilowatt or 2 kilowatt. But if I use heater, the kilowatt will be maybe much more higher than coil load, right? So say for example, based on the delta T, right, 12 degree and 24 degree, what is the delta T? 12 degree, okay? To increase the 12 degree, if I go to the equation, if I calculate sensible load, it may give you like a 20 kilowatt. That will we will see in the duct heater portion, okay? How why the duct heater is required or the heater is required, clear, right? So you have to see that which is the best option, whether to go with a sensible wheel or to go with the heat pipe or go with the duct heater. So which is the best energy consumption? So based on that you will decide, okay? But this is the way you calculate your total sensible load and latent load or total load, okay, with you by using different equipments. Is everyone clear how to calculate sensible load and total load? So if I go to one of the schedule, okay, this is my previous project schedule, you can see this is my FAHU, right? You can see the different condition 3432 as per local regulations, right? This is 2518.7 which comes from the room, okay? So whatever the cold air will try to transfer the air energy, right? It will transfer his energy, okay? The 25 is higher, 12.8 is lower. So what will happen ultimately? The hotter temperature will go to the colder temperature, and cold temperature will become hot, right? So here you can see the after the coil, you can see the temperature. What is the condition you are going to achieve? 20.8 or 15.3, right? So that is why you are using the sensible wheel. Okay. So if you go to the software from the manufacturer, if you enter this value and if you enter this value and if you enter the airflow rate, it will give you clearly that what is the off wheel condition, off coil condition, or off coil, off sensible wheel load. What is the load? It will give you the conditions here. Exactly. So everyone clear, right? Any doubt?
No, sir.
You are clear how FHU is calculated?